Hello. Morning, evening, afternoon, the usual. I hope everyone's having a pleasant Wednesday. Thank you for coming along on a Wednesday to watch some more C++ and watch me battle my way through some more OpenGL from scratch. So, I guess if you're new, welcome. We are trying to build a simple game in 3D from scratch with C++ and OpenGL. And if you're returning, then thank you for coming back. We are trying to build a simple game in scratch from C++ with OpenGL. We left Sunday with this rather sad looking distorted triangle, which is not quite what we wanted. We wanted, something that wasn't this. We wanted to be able to freely kind of move around, have some of the perspective set up. So I thought about this for a bit, and my initial plan was like, oh, there's clearly a bug in the matrix math somewhere, like I can probably figure this out, fix it up, and then what I'll do is I won't commit anything, and then on the next stream, which will be today, I'd kind of go through what the problem was and then fix it up with everyone, and then we go. So but then I thought, actually, what a lot of people have said is that they're kind of enjoying seeing, like, I guess, like my thought process and how I tackle these problems and how we design stuff out. So I thought, actually, I'll pick this slightly harder way and not do it quietly by myself, maybe over a couple of beers, but instead, in front of a live audience. So today we're going to try and just figure out what the issue is with the matrix maths, and I'm going to kind of show how I would maybe approach this kind of debugging problem. So that's going to be the plan today. I'm hoping by the end of this stream, we'll have the ability to construct a camera, and then we can get onto some more actual rendering stuff. So that's the plan. That is the plan. So, what I want to start off with is, as always, sort of code review from the previous time, because people rewatch this or leave comments on the video, which is very much appreciated. And two people pointed out an issue with what we did on Sunday, and that is all the way down here. So we've got a matrix class, okay? It stores 16 floating point element, or 16 elements of floats. So it's a 4x4 matrix, and conventionally there's kind of two ways of interpreting that data, which is called row major and column major. So the idea is that you either store the first four elements as the first row, and then the next four elements as the second row, etc., or you do the first four elements of the first column and the second four elements of the next column, blah blah blah. It's kind of a convention, like it does affect how the maths works, but it's quite easy to get bogged down in this. And for me, the most important thing is, like, what does OpenGL care about? Like, you want to transfer an array of floats to OpenGL in a format that it kind of understands, and that happens to be column major. So we added this format specialization to allow us to print the matrix, so we could pass it to std print ln and std format. And someone pointed out that I'm actually printing out here these in row major format, which I think is wrong, because I want to be able to print these out in sort of the which is wrong, because basically I'm treating these first four elements here as the first column, and if you're printing them out with new lines here, I'm actually printing them out as the row. And you could argue whether this matters or not, because again, these are in the format that OpenGL expects. However, when you want to print them out, I want them to be formatted in like what you consider like the mathematical notation, which is columns and rows. So last stream, when we're like, we printed out some maths, and then we went to Wolfram and we printed out, like, oh, it looks the same, so what's going on here? I think this is actually wrong. So the first thing I want to do is just kind of fix this up. So really what I need to be doing is printing them out so that they make sense in the mathematical notation, if that makes sense. So I'm going to just fix that up first, and then we'll dive into how to go about sort of debugging the mess that we've got. Just one second. Hang on. So if we're in column major, then that means every fourth element needs to be the next one. So 0, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Is this right? So it's going to be 0, 0, 1, 2. I'm going to get this wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 4, 0, 1. I'm just going to have to draw this out. So I've got 0, 1, 2, 3, and then 4, 5, 6, 7, and then 8, 9, 10, 11, and then 12, 13, 14, 15, right. Yeah, so 0, 4, 8, 12, so I definitely had gotten that wrong. 1, 5, 9, 13, and then 2, 6, 10, 14, and then 3, 7, 11, 15, right, nailed it. So okay, that's just the first thing I wanted to kind of fix up there. Let's just see that in action. You could align them as a matrix. Problem is, the clang format is a little bit funny with stuff like that, and I don't really want to spend too much of my evening faffing around with the formatter. Okay, cool. So this now is in the mathematical notation with columns and rows, formatted like that. But then internally we know that this is the first 4 elements are here, then the next are here, etc., etc. Okay, just quickly commit that up. So commit fix matrix format. Okay, right. So what made me choose OpenGL? It's a great question. I probably know it the best out of the graphics APIs, and that doesn't mean I know it well. It just means that I know it. I've had more experience with it than, say, Vulkan and DirectX 12 and Metal, which I've experimented all with before. They are just very complex. Like, I guess I could have used DirectX 11, but I've never really used that at all. I just kind of, when in my own kind of personal experiments, I kind of jumped straight to 12. So, but I've been playing with OpenGL for years, so I kind of know a bit better, and I think conceptually it is easier to work with because it's just like, a state machine with a lot of magic underneath it. So I think you can get pretty far with OpenGL, and for what I want to do, it will definitely be good enough. So I think we want to do, I think it'll be good enough. Okay, so we know that we are constructing a lookout matrix and a perspective matrix, and we know that is wrong somewhere, or potentially the multiplication is wrong as well. So for me, I think I've kind of been less than diligent in sort of engineering here, in the sense that we've got a bunch of maths classes and functions, and they are basically kind of pure functions in a lot of sense. They take some data, they manipulate it, and they return a value. This kind of feels to me like it should be tested, and I've not done it. So what I'm going to do is the first thing I would actually do when I want to debug something is try to construct a test that fails, because then that kind of helps you narrow down where the problem is. So I'm going to build out some unit tests for what we've got. Well, first of all, we're going to build out a little unit testing executable, bring in a testing framework. So I'm not going to write my own. I will actually reach out to something for that. And then we're going to see if we can find some ground truths for some matrix multiplications. There must be some ground truth out there that we can compare against, and then from there you kind of figure out where our issues are. So that's the plan. It's going to be a little bit of like mechanics and typing out, but I think it will leave us in a much better place going forward, and it should be a lot easier to kind of fix these things afterwards. Hey Beef, good for you to, glad you could join us on a Wednesday. Okay, right, so the first thing for me for this kind of thing is we need to bring in a unit test framework. My personal preference is Gtest or Google Test. all unit testing frameworks basically do the same. They're all which means they all have various degrees of like being good and terrible. I know Google Test better than anything else, so that's what I'll use. And also, I like Google Test because it comes bundled with Gmock, which is, if you need it, is incredibly powerful. I don't know if we're going to need it. I don't know if we're going to need to do much mocking, but it's kind of nice to have anyway. So I like to drive as much as I can through like the build system. So CMake has, I don't know what you call it in CMake, like an extension or, you know, a thing that you can include called fetch content. And fetch content is great because it will basically reach out and check out a repository for you through Git. I think it also maybe supports SVN and some of the others, but like it definitely supports Git. But what's nice about it is if the thing you're checking out is itself a CMake project, CMake kind of takes it all and handles it, and it makes it very easy to integrate another project. So you don't have to worry about checking stuff out, you don't have to worry about checking in anything, you just kind of add some CMake runes and then it does everything for you. So fetch content declare, so I'm going to want Google Test, and then I'm going to want, which I should have looked up before, the Google Test repo. So then you do git repository and then that. And then what I personally like to do for this, again, this is more personal preferences, I like to check out a specific version. It's normally whatever the latest one is at the time of checking out. It's just because I don't want Google to push a breaking change to their project. I'm not saying they will, but like if they push a breaking change to their project, I'm always pulling master, then I might mean that one, you know, I'll go to bed one day, then I wake up the next, and now my code doesn't build. So I'd rather pin to a specific version and then upgrade as and when I need, sort of on my terms. So I can see that their latest version is 1.15.2, and I believe they tag their repos with the version, so that should work. We can close that. And then we can do fetch content. There's a few like weird runes with fetch content. Get properties Google Test. This effectively introduces like almost like I think it's a target. So I can kind of refer to the thing that the content that I've declared as Google Test. Now I can call this whatever I want. It just makes sense to call it the same thing as the repo. So also here, and another good one to do is fetch content quiet false. All this means is that CMake will then print out some like more verbose output when it's doing this, because if it's a big repo it's got to check out, it can look like it's kind of stalled. Someone else has tried fetch content before. Beef, yep. It's a little bit hit and miss depending on how well the CMake project that you're pulling is configured. Google is pretty good with their CMake integration. I mean, I know they have, was it Bazel, but their CMake stuff is pretty good as well. So then after this, I want to enable testing and then include, I believe the order of this is quite sensitive, and then add sub directory tests. So this will then just sort of activate the C test, which is the testing runner built into CMake. Let's mukta tests, and then E tests. Oh, what's going on? Fine, okay. And then E tests, and then I'm going to do CMake lists.text. I misspelt it, almost certainly because I'm a terrible typist, terrible speller, terrible at most things. So in these tests, will it compile a different project that runs the code, like simulation? So it's kind of a good point. Like, how do you actually kind of structure this? So normally, when I normally write C++ projects, especially like a smallish personal one, I would put all the code into a library and then have just a executable that is just effectively a thin wrapper around that library that just drives the code. That means I can have a separate test executable and just link that in. I've opted not to do that for this because I don't want to get into the trap of trying to build like a library, a framework, an engine. I want to just build a game, so that should just be an executable. So for the tests, we will probably have to recompile the specific bits of code that we want into the unit test, but I'm not that fussed about that. Like, we're not going to be unit testing everything. It's really hard to unit test graphical stuff anyway, so we're probably going to do it more for some of these like base classes and helper classes, but it's just once it's set up, it'll be there, and it's kind of good for us to get going with. So fetch content, make available Google test, and then include. I should be able to now include Google test. And then there's a good one here called Mark has advanced build Gmock. I've got some notes on this, by the way. I'm not just doing this all from memory. I'm looking at a previous project that I've done this on. Gtest hide internal symbols. This just prevents you from exporting any of the internal stuff for Gtest, which means it kind of helps with like autocomplete. It doesn't, it means you don't accidentally, your toolchain is less likely to report errors inside Google's code, and it also means if you are packaging it up into a final product, it won't shift a load of like the Google test stuff with it. It's more important for libraries, but this is just one of the things I tend to just sort of include out of habit. As executable, and we're going to call this unit tests, and then we're going to have. I'm just going to do vector3 tests.cpp first. We'll write that in a second, and that's just more because I'm pretty sure vector3 works. It's kind of just a good starting point for us. Does the capital G on the include matter as it was lowercase before? I think this, if I remember correctly, is not including the target that I mentioned. I think this is including something specific to Google within CMake, because C-test understands certain things about the common testing frameworks like Boost and Catch and Google. So it's a good point, but I believe this is basically saying, hey, just so you know, the unit tests here are going to be G-test. So C-test can be like, okay, I know how to drive that. I know how to pass the output. Yeah, good point. Good question. Target link libraries. I'm not a CMake expert, by the way. Unit tests, and then the main one for me is Gmake main. So Gmock main, because Gmock main is a pre-built library that comes with Gtest or Google test, and it already includes an int main function, which means I don't now have to define one. This one here, again, it's kind of got all the magic in it for automatically discovering your tests and running them and giving you same command line arguments. So this literally just means if I just put all my tests into CPP files and link that with Gmock main, then the whole thing kind of just runs. And then finally, I think part of the magic is gtest discover tests. I believe include gtest is what gives you access to this function here, if I remember correctly. And then unit tests discovery mode pretest. Okay, so this should work. So what we're going to do is we're going to create a vector3 tests.cpp, and let's get up our vector. I probably won't find the include to start with, but that's okay. We can fix that. Include vector3.h, and then hash include gtest/gtest.h. Did you fix the enable tetting? No, I did not. Thank you. Good spot. I should have noticed that because the color was wrong. Good spot. Glad someone's paying attention. And then test vector3. I always like to use just like something simple like this, just like assert true false. Like it's just a failing test. This will just kind of test that we've got all the bits in place. So this isn't going to work. So that's going to fix everything here, and then we'll write a couple of vector tests. See how it's giving me the output from G tests now. Yeah, that's a good point. The initial pull will bring in all the libraries, and then CMake should wire everything up. But yeah, fetch content is really useful. It does kind of work if you have not. There are ways of getting it to work if it's a non-CMake project. I think you can have like auto tools configure and stuff, or if it's header only. But it shouldn't take too long to build. But if we have a look in _deps, you can see in the build directory, this is where it starts building everything out to, and you'll get a source directory and then a build directory as well. So this should have the source in it, and then build should have the build chuff in it. I don't know why this is taking so long. It's a little bit sad. Yeah, it's not. I would expect it to be a little bit more talkative, as in like at least. This is interesting though. CMake have libc pthread failed. I'm hoping this isn't going to be some weird quirk of my weird build setup. Although I've definitely done this before with WSL. Like this definitely worked. When on the last, in fact, I had C-test. I had C-test with G-test in the last live stream series I did through the WSL setup, and it definitely worked. In fact, the CMake code I've been cribbing that I can sort of got off screen is from the Blind.io project. So I'm struggling to understand why this isn't working. Let's just try that again. Let's just configure it first. Thanks. Cool. Yeah. Thanks, Simon. You can use fetch content to download anything, even a zip or whatever, then unzip it. That's good. Good to know. Okay. So that cannot open vector3, which is what I was expecting, because I now need to go to tests, CMake tests, and then target include directories, and then unit tests, public, and then project I think it's project and that would be source. I think that's right. I think it's project is the root one. CMake project variable. Project source there. But I will need this. Someone's saying that I don't need this because it's relative, but I'm in a separate subdirectory, so I guess I could go up one and in, but I prefer to kind of, as I'm glancing at it, this is very obvious to me where I'm getting the source from, where I'm linking to. Maybe that's more of a personal preference. I think you should use CMake presets JSON. It's easy to configure, build, and test. I've never actually really looked at it. I've always just done it from scratch. So maybe I'm misinformed. Maybe there's a better way I could do it. Maybe I'll have a look at that. Okay, now, yes, so now, because I'm including it again and building it again in the unit tests, I have to make sure that I pass in the same build flags, which is a little bit annoying because because these are public, if I'd linked it as a library, it would bring those across automatically, but it's not the end of the world. What I'll do is bring those across, and then we'll just do game and then do unit tests. I'm very much an advocate of treating your tests like any other code, so try and make it good quality code, kind of it forms part of the documentation, I think, to a certain extent. ctest dot. Okay, fine. We've got a test. It fails. Let's close that down. Go to vector tests and true and build. Nice. Nailed it. All the tests pass. Where's my DB? Just update my definitions. Whoa. Sure, I'm sure it's fine. Okay, so let's just have a quick look at vector 3 and just write a couple of tests for it. Yeah, so thanks. Yeah, it's good to have the advice about setting up a config interface, and thank you for arriving, and hope you're enjoying it and hope you stay. I'm not a CMake expert. I kind of know enough to be dangerous, but I say that about quite a lot of things. I guess CMake is probably on my list to kind of, I'd like to be a little bit more like, be a little better at it, I think is what I'm trying to say. There's definitely tips and tricks and definitely ways of optimizing how I use CMake. Again, I kind of know enough just to get something building and hopefully not make too much of a mess, because I've read some pretty awful CMake files before, and I try to not do that. Oh, that's cool. You do CMake courses and talks. That's good to know. Yeah, well, shout out anything I'm doing wrong, and if it makes sense, I'll kind of incorporate it as I go along. But it's a pretty basic setup. I literally just have a subdirectory with all my source in it, which just builds everything into an executable, and then has some target options, and then the tests has something kind of similar. Like I said before, I normally build everything into a library and then link that in, but I'm doing something slightly different this time, and I want to focus more on just the focus just mentally and on the layout of just building a single executable. Using Raylib, great library, would absolutely recommend it. And I've never actually used Raylib before, but I've heard good things about it, and I would definitely recommend using a library over whatever horror we're doing. But people are here and they seem to be enjoying it, and I'm enjoying it, so we're going to keep going. Okay, let's do... I'm only going to write one test just to kind of prove everything works. If we got time at the end of the stream, then we might go back and, as we're chatting, just add some more tests. Vector is not, I don't think, is the issue, but at least it's kind of there for us to add to if we need to. Also, I'm not taking into account floating point diffs, so I'm hoping these are going to just kind of work for me. I want to move the fetch comment variable closer to the declare. Okay, I can move that in a minute. Is that because I'm not using the designated initializer syntax? Let's just fix that up. I'm hoping that's it. I've missed a semicolon. I have. Wow, what a schoolboy error that is. It's been a while since I missed the semicolon. Too many arguments for function assert equal syntax error minus. That should be that should be negated as well. Change it to .y equals. Thank you. We're getting there. We're slowly getting there. I don't know why it doesn't like my assert equal. I'm pretty sure that's right. Use comma separated. Function does not take 3 arguments. I've clearly got a syntax error somewhere. What am I? Oh, hang on. No. Hard to see you. That is an excellent point. My big old mug is hiding the code. Let's just too many argument asserts. Oh, is it? I bet it doesn't like the curly brace syntax inside the macro. I bet that's it. I wonder if I can just force it to evaluate it as like an expression. Right, okay, fine. So let's do const auto v1 equals dot x equals 1.0f dot y equals 2.0f dot z equals 3.0f. Right, and then do const auto expected equals v1. Right, expected f1 minus f2 minus and f3 minus. Okay, fine. Now assert equals minus v1 to expected. It should be vector 3. Yep. Game. So I'm coming off. I don't know. I use this excuse on Sunday. I'm going to keep using it today. I've been a bit ill for the last few days, so that is my excuse for making terrible mistakes. Yep. It's saying the error's here. I don't understand. I really don't want to spend ages. This is like the bits to get to the bit that I want to do to fix the thing that I didn't get to fix on Sunday, so we can get to the bit that I actually want to do. No. Oh, of course. Of course. All right. Okay. Now we need const expr. I actually need to tell it how to do equality. Const expr auto operator equals const vector 3 const bool equals default. Right. And as of C++ 20, I want to say, defining an equality operator implicitly gives you the inequality operator as well. So I could use the spaceship operator, but then the question is, like, what does it mean for like one vector to be less than or greater than another, conceptually? So I did think about it, but I think I was going to do with just keep it straight with the equality operator to start with. Because I don't want to more functionality than I need, if that makes sense. And also I think it's then confusing if I could then be like this vector is less than another. Okay, nailed it. Right, okay. Whew. Getting there. Matrix. So that's the one I actually care about. So let's go with that. So e tests matrix for test.hpp, not.h. Nope, it's CPP. Oh my goodness. Right. CPP. There you go. And then where's my vector tests? I'll just yank this and we'll put in matrix 4. Same thing before. I don't know why I always just do like just to kind of prove to myself that it's all wired up correctly, have something that just fails to start with. And then into the CMake, test CMake, and then we're going to do matrix 4. So hopefully we'll see this failing. I just roll the dice every time in my mind on what the file extension is going to be. Just could be anything. Could be .py next. Okay, right. So that's wired in. Okay, so what do we want to check? So there's lots of stuff to test. I don't really want to I want to kind of just focus on for the here and now on the bits that we know are potentially broken. We can kind of add to this as we go along because it just provides us a framework. So what we want to do is, let me get the render up. Again, not the best rendering code in the world, but it's enough to get started. We're going to use the program, and then we kind of hard-coded the model view and the projection because we just have one thing we're going to render at the moment, so there's just one hard-coded mesh. We're pretty sure the model is right because when we didn't have the view or the projection, we could move this left and right, and that worked. So I'm reasonably happy that the model is fine. And then it's when we started adding the view and the projection, that's when we started having some issues. So I guess the first point of call for us is to check the view, the look at. What I'm going to do is I'm going to construct right, let's just do it. So before we forget, let's quickly add const for auto operator const matrix 4 const bool equals default. Just add that before we forget. Yeah, so we could write a test for each transform isolation. So I'm going to just what I want to do is, first of all, I think we might end up doing that. I just want to just check that the output of this in its kind of entirety, whether that is correct or not. So what I'm going to do is I'm going to basically use GLM, the maths library you should be using, to find out what its look at is for a given set, and then we'll compare that to ours, and that'll be kind of like the base case. The friend keyword allows the thing that you're declaring as a friend to access the private members of your class, basically. So because I have a freeform operator, which I could have done it as a member function, but there are reasons to do it as a freeform function. This needs access to the internals because it needs to access the elements. I think the culprit is this. But again, I don't want to guess. I want to know. Okay, right. So look at tests. Nope. Tests matrix. So let's do look at, and then we're going to do const auto m equals game matrix 4 look at, and then we're gonna do, let's take the one from the renderer, that would be easier. So and now we need That's cool. Being invited to participate with SG15. That's really cool. I'd love to get involved in some of the standardization stuff. I just not had the time or the kind of drive to do it yet. But that's cool that you've been invited on. Hopefully, you kind of like C++ tooling is definitely an area that could be improved, or at least not necessarily improved, because I think the tooling is pretty good. It's just not very standardized, which I guess is probably the point of SG15. So that's pretty cool. Test for the multiplication with the identity matrix first. Sure. Okay, fine. Good. I'm happy to do that. Let's just get us something somewhere. So we're gonna do we're gonna do game. Const auto m1 equals game matrix 4 and then on f2 f3 f4 so it's and then we have defined I believe our default constructor gives us the identity matrix. So const auto m2 equals game matrix, and then we do assert equals m1 times m2 is equal to m1. I think that's what we're saying. So any matrix multiplied by the identity matrix should give itself. So I guess if this doesn't work, then we do have a problem. Yes, I'll go through this comes up a lot, and I think, like I say, it's always good with it comes up a lot because it means there's new people coming to the stream, because I mention this all the time, but I will go through it. The prefacing anything with the colon is accessing anything that's in the global namespace. So that's effectively everything that your translation unit can currently see and use. This gives you access to it. But why? I guess there's kind of two reasons. One, as you've seen here, it instantly kicks off the autocomplete, which is kind of handy. But two, for me, what I use it for is to signify a function that I didn't write. So anything that comes from the platform or a third-party library, I preface it with that. So then if you see in the, say for instance, the rendering code, at a glance, I now know these are all functions that I didn't write. And that's personal preference, but that's just one of the reasons I use it. But yeah, there's has no actual effect on the output of the code, if that makes sense. Technically, std itself is in the global namespace, so you can do : std and then something. I would encourage you not to do that because I think it looks really strange. I have worked on a code base which enforced that before. I feel it added very little, but it sure did look strange. Okay, so that works. So that's good. So we're probably okay on that front. Okay. So right. Let's get up. So I believe Godbolt allows you to interact with GLM, which is pretty cool. So, because I don't really want to bring it down and compile it and figure out how to use it just to throw it away. So I think, so output, execute the code, bring that over here, increase the font size, and then dash std equals C++23. And then let's just check this works, put the Vim mode on, because otherwise I can't use it. Hash include print imp main std print on hello. Not even hello world. Don't have time. Too busy. Yeah, sometimes that is a good point. The colon is useful if you have shadowing. If you have a function in your class, for instance, that is the name of a free form function, then it can disambiguate which one you call. So, because I believe the language says it will prefer, from within a class member, it will prefer other class members first, other than the global ones. So, just that is useful in that case. So yeah. Nailed it. Right, okay, so I think in here we can go libraries, and then Godbot has all these libraries that you can bring in. I believe GLM is one of them, so I can just bring in the latest. And it's got libraries here, and now I need to go and figure out how to use GLM. I want apparently this hash. Oh, Godbot, what are you doing? Help. Include glm/mat 4x4.hpp. Let's just see if that compiles. Okay, cool. Okay, so I think I can now. So here I would do colon GLM just to signify that. Again, this is just like code I'm throwing together, but out of habit, I will probably be writing this. Map for, I believe GLM has a look at function, which is modeled very closely on the one that I did. I think it takes an I, a center, and an up. So I think we can do whatever. What was our 105 1.0 0.0 5.0 f, and then 0.0 f 0.0 f 0.0 f, and then 0.0 f 1.0 f 0.0 f. Right, let's just see if that blends first. It does not. No matching constructor for mat race initialized list. Okay, do I need to bring in something else? So this is going to be a little bit of a trial and error as I figure out how to use GLM. Where is it in the OpenGL guide? That's probably what I want. Look at camera. Here we go. Oh, right. Right. Look at here. We go. Okay. This is what I want. Da, 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 da. Okay, fine. We'll just yoink that. Thank you very much. Where's paste? What? Copy. Okay, fine. Equals GLM look at. I think I might have just typed that in wrong before thinking about it, but it doesn't matter. Yeah, I was calling the matrix constructor. I've just realised what I was doing. Thank you. I'm glad someone's paying attention. Look at is not a member of GLM. Well, where does that live then? Has it got like a God header? Some GLM view. So this GM look at, like, what am I missing? Look at is not a member of GLM. Is it not even in the God header? Why even have one? I want matrix transform. Okay, cool. Thanks. Nice. Okay, cool. So now I am hoping. I doubt it's got print support, but I'm hoping that at the very least I can just stream this to stood out, just so we can kind of see what it looks like. View. Need to change those numbers to your ones. Yes, I do. Good shout. So we got 105, 105. Okay. Also, as an aside, so it doesn't support C out the box, which is a shame, but I'm sure there must be a way of printing it, and I'll just look that up in a second. What I think this here is one of when I sort of teach C++, this is one of the examples I give of like why C++ gives such miserable errors. Defining a class, a new class, so introducing a new type into the type system and passing that to C out, which obviously it won't like, generates like thousands and thousands and thousands of lines of errors. Like the first one is like no matching operator, but then it's like, what is all this? And C++ is, this is a bit of a tangent, but C++ is C++ is a bit strange, right? It might not feel like it, but it's on your side, okay? It does want your code to work. It doesn't always feel like it. What it's allowed to do is it's allowed to do one implicit cast to a type that it does understand. So what that kind of means is because this here operator is just a function call, right? So I'm just calling a function effectively. That's all the operator overloading is doing. It's allowed to do one cast of this type to something it does know how to print. And what all these errors are is it basically saying, here's all the things I tried and didn't work. It's like, I know how to print an unsigned long, but I can't convert a matrix to that. I know how to print a long, but I don't know how to convert a matrix to that. I know how to print, all these types. It's going to go through every single one it tried and then failed and put those in the error message. And it's like, great, thanks. That's really, I mean, I'm sure it is maybe useful, but when like the first 4 lines of the bit you actually care about, this is why C++ gets a bit of a bad rep with error messages, because it literally dumps everything it thinks might be useful to you. Anyway, bit of an aside. Someone is looking ahead and telling me that I can include GLM GTC stringcast. Let's hope so. Maybe that brings in the operator overload. GTX. Nope. Try it again. What was that? GLM print matrix. How do I print a vector? You do need string cast, but you also need GLM toString. Oh, what a horrible API. Like, again, I've not written a hugely popular maths open source library, so I can't really complain too much, but like, I don't think that is great interface design, personally. Having to remember to import random extra head, like, I think being able to print something is such a fundamental use case for any class you create. I feel like it should just kind of come with the definition, but here we are, and we've solved it. Okay, so this is interesting because I don't know what order this is in, right? I know that GLM under the hood is column major because that is what it's designed to be, sort of work seamlessly with OpenGL. Is this the first column or is this the first row? Your guess is a good amount. So what we now need to do actually is kind of get the raw data out of this. So how does this? Where's the view matrix? Where does this actually get passed to the GL uniform? Our shader. Where's our shader? Has he got like a shader? He's got like a shader class, shader M. So Matt, here we go. So it uses the. Okay, it just takes to get the address, to get a pointer to the first element, which is all you really care about. You only really care about like an array of floats, right? You can just apparently do this. So const auto pointer equals view 0 0, and then for auto I equals 0u, I is less than 16u plus I std print pointer I, and then std print ln. Someone has written a paper to add a no argument version of println, which just prints a line without having to do this, and I really appreciate that, and I really hope that gets put in. Okay, so this looks to me like 090090001 minus 0, which is 0 0 minus 1. Okay, fine. So this is the column, right? This is so the raw. If you just squirt the raw data straight out to std out, then this is what you get. And then if you use their built-in formatter, then we can see that this is column first. Okay, which kind of makes sense because it's column major. Right. Okay. So now we've got to go and look at ours. And what I'm going to do is I'm going to take this because we know it to be correct. And then go const auto expected equals game matrix 4. And just fix this up quick. I'm gonna hopefully just, I'll put the F's in later. Alright. No, in fact, actually, like, I know you get the implicit cast from double to float, but I just like it. It's like being explicit about it. Right, assert equals now view and expected. Is it normal to initialize a 4x4 matrix with 3 vec3s in this lib? Which lib? My lib or the I say my lib or the GLM lib? The answer is I don't know, because I don't really know what is normal, because I've never worked in the games industry. I'm largely just making this up as I go along. Yeah, I couldn't attest. Maybe someone in the chat knows, but I couldn't attest to the design decisions of GLM. Okay, failed. Interesting. Okay, so there is an issue somewhere. Annoyingly, this won't print out which one it is. Is there a way we can do that? I'd rather rely on the tooling to tell me which is the yeah, I mean, I have to print them, I guess. I was kind of hoping to not have to do that. Yeah, all compare them one by one. What I'm trying to say is what I really want is to So there's an excellent point that's just come in, and I will address that in a second. This could just be an error from floating point comparison, but also I'd rather just like use tooling which said here's a collection of items, like the nth one is incorrect, which you can. I wonder if it'll do it with. I wonder if gtest is smart enough to do it with a span. That would be nice. Yeah, but I don't have any. Is there no operator overload for? Is there no equality operator for span? I thought. Really? I'm surprised. No. Interesting. Okay. Fine. So yeah, I think the question now is it wrong, or is it just only, is it a little bit wrong because of floating point, or is it a lot wrong because the maths is wrong? That's kind of the game. We're just going to do them one by one, aren't we? Cert equals view const auto view pointer equals view. I want to change this method to not be called .data anymore because I have to keep calling data and it actually quite upsets me. Data, and then we can do view pointer I, and then expected pointer I. This is gross and I don't like it, but here we are. Yeah, so we can use gtest will have will allow us to handle floating point diffs rather than absolute diffs, I guess. But let's just see if that's the issue first. Failure. I was hoping for something a bit more verbose than this. There we go. That's what I wanted. Right. So it does look like it's a floating point issue. Okay, which is good. So I think someone's already pointed out what we need to do. We need to do assert float equals. So I'm not going to go into like the weeds of floating point numbers, but they don't, due to their limitations, there's certain numbers that they cannot fully represent, and there's an inherent like rounding issue with them. They are not the real numbers can be infinitely precise, like pi, for instance, just keeps on going. So whenever you store them in bits, there is an inherent like reduction in the potential, I guess, like accuracy of them. And then this kind of comes into play when you try and compare them as well, because actually two floats can be like very close, but because the rounding errors still be equal as a like super high level. There's a really good article on this by one of the Chrome engineers. I'll see if I can find it. It's really good. Yes, this here is the Random ASCII blog. I don't know if he still is, but he used to be an engineer for Chrome, I believe. He's got a really interesting article on floating point numbers. He's got several of them, and all to do with like the diffs, because conceptually you just like pick like a small epsilon and then just subtract them, and if they're under that epsilon then they're considered the same. But actually it turns out as the floating point numbers get bigger, that epsilon needs to scale. It's really interesting. He's still working on Chromium. Cool. I think did I meet him? I can't remember if I bumped into him. someone from the Chrome team when I went to many years ago. I went to the Microsoft Build conference, and there was someone there from the Chrome team, I think. Of course, Studspan has an operator. Sorry, this is one of the things with, like, doing stuff live, is that I kind of get wrapped up to it, and because I'm talking and doing stuff, it takes kind of a second for me to kind of realize all the, remember some of the intricacies of C++. So let's just see if we can get this going, and then I will do that. You're right. Microsoft Build. Link to paper in the chat. Yeah, that's a good point. Let me just pop this in here and in here. It's not just that. There's a whole series of articles he's done that. So this is interesting. So this still looks pretty close. So is it an issue? Yes, thank you. I was being silly. Caps lock on, so immediately Vim has an absolute mare. ZO string sentry to also truncate the string to float. Is it because well, these are still within a floating point precision, right? These are not having enough points to, thank you. So I might need to round them up. Okay, was that what someone was suggesting then? Can you do that with GLM? This is, by the way, this is kind of how I debug. It's just sort of like try and find some ground truth and then kind of keep iterating on stuff and playing around with it. So it's kind of fun to do it with people rather than just sort of sitting here getting miserable by myself. GLM ZO string. Is that, where would I do that? Do I wrap that in this? Lots of suggestions coming in, and I'm struggling to keep up with it all. So I think that this ZO, I'm interested in this GLM ZO string. I am not finding any. Oh, unless, did you typo? Should that be toString rather than ZO string? I was like, I didn't know if ZO was some sort of like GLM construct that I was unaware of. I think what we can do is just reduce the precision of this. I think someone was saying we only want like 4 or 5 decimal places. Right, 1, 2, 3, 4. So let's just, I don't know, try that. Still not liking it, but that's a different number now, right? Like this is not the one that it didn't like before, and it still looks pretty close. So 9805. Is it because I just knocked off the last 2 digits rather than like properly rounding it? You can also give G-test a margin with a cert near. Do I supply it like some sort of function that checks it? Yes, it's going okay. I was hoping to be a little bit further on tonight than we are, because I still haven't actually kind of I'm now fighting with floating point numbers rather than actually trying to fix the underlying error. But so what we're saying, assert near, and then what, like 0.01 f, something like that. Okay, fine. I'm really not too fussed about this. That is, I think, good enough to kind of. Well, I will ask everyone in the chat. Do we think that this is good enough to convince us that the maths is right and it's just the float? It's the floats that are wrong. I'm reasonably convinced that our look at is correct. Okay, right. So it must be the projection matrix? Question mark? Because we know this is right, and we know this is right, and we know that we know this is wrong. So the only remaining thing I think is the projection matrix. Okay, right. Because the idea is that I should be able to just move the camera along and the whole triangle should shift. Unless the whole thing is right and we've just made a mistake. No, because I can't remember what we did last time. We had a specific case where it looked really strange. Regardless, even if we should verify all this anyway, because this is going to underpin a lot of the stuff we do going forward. Oops, right. Okay, so now I've got to get the perspective matrix. So let's see if we can find that. Perspective is, that looks very similar to what I've got, which is good. Right. Just gonna C style casts. It's painful to look at, but it's what we've got. I think my near buffer is my near plane is a bit too narrow. And then I used 800 by 600. Oh, they don't supply differently. Interesting. Okay, let's just have a look at what I actually do then. Do I just immediately divide them and never use them again? Okay, fine. That's fine. I just do the maths. Okay, so that's 800.0f over 600.0f. Yes, the projection matrix has to be correct. I think we came to this point last time because I tried to do a cop out and was just like, oh well, we can just worry about the projection matrix next time. And then I think that's how we ended down this route. Yeah, thank you. Sorry, I was distracted. That was, I mean, it was a typo, but it was only because I kind of got distracted halfway through. Okay, fine. So now we can, let's just get rid of the view. We don't need it. And then we can just go view and then change all these to projection. And then objection. Okay. Let's just see if this prints anything out. We did. Oh, I remember. So for those who were here on Sunday, it was getting towards the end of the stream, and I was like, one last thing. Let's just throw in a projection, literally like Blue Peter, like here's one I made earlier. Throw it in and see what happens, and it did not go well. Okay, right. Okay, so let's just set up the similar deal to what we've got here, which is perspective, and we'll call this proj, and we'll nick it from the renderer. The nice thing is once the math is kind of sorted, quote unquote sorted, then we don't really have to worry too much about it after that because we're not going to be doing anything too crazy. numbers, game. Okay, let's get rid of this, a bit more space. So we can now take our expected, which will be this. Copy. Nothing like copy and pasting. Arbitrary maths. Oh, my goodness. Okay, so shift insert works on NeoVim, but doesn't work on Godbolt. Yes, I'm using a mouse. No, I don't care. Let's get rid of these random numbers. I suspect I'm missing. There you go. Right. Okay. Okay. So. View CFW Brodge. Alright. See if this works. If this works, then I'm out of ideas. Thank you. Thank you. Visual, like sort of visual insert is super useful. Did it? Have I? What? Has it just like worked the whole time and I've just wasted everyone's evening? So yeah, thank you for keeping me grounded. Some things to investigate first before we just write off today as a waste of time. You see, that's not what I expect, right? I've moved the camera more to the right and it's just skewed it, but the triangle should be on the XY plane at the center, right? And then the camera should just move to the right. We could render dock it, but I don't. Yeah, okay. Let's right. People have made lots of suggestions, and I think they're all good. So let's kind of go through them one by one. So we can check the multiplication order. That's a good point. That is in main. Projection. Oh no. Oh no, it is right. It is projection. It is projection view model. I'm pretty sure that's right. Yeah, it looks like moving right has rotated the camera. Oh crap! You're right. I'm looking at 0, 0. Is that? Yeah. I think. This is going to be so embarrassing. I think that's right, isn't it? Isn't that exactly what we wanted? So, So it turns out I am actually a genius and I got all the maths right first time. I just didn't know how to put all the bits together. So I think, yeah, let's right, so let's do this. let's. So let me just respond to this quickly. Thanks very much. It is indeed a sick triangle. I can concur. It is one of the best triangles I've ever rendered. Not only because we spent nearly an hour and a half correctly rendering it, but arguing about the angle we were looking at it. Let's see if I can remember how this works. So let's do static auto x equals 2.0f static auto z equals 0.f, and then static auto t equals 0.0 f. So, and we can do x equals stood sine of. I'm trying to get it to move in a circle. I want to rotate it around a circle, if that makes sense. No, you don't need snif because as of C++, whatever it is, 11, this is templated, so it'll pick up the right type. I want sine t, right, times 2.0f, and then z equals cos, and then t plus equals 0.01f, 0.1f, something like that. And then x, and then z, I think. Unlikely to be that. Is it plus? Oh, and as a look point. Yes. Nope. It's not moving. It's not moving. Why is it not moving? Unless this delta is too small, which is probably the case. Yes, I'm feeling better today. I'm going to say Vinzez, and if that's not how you pronounce your name, I do apologise. I will say that I go by Nathan rather than Nate. Can you convince yourself that the pixels are shifting slightly? I don't think so. Why is this? Unless I do need to multiply it. What have you missed? It's been a roller coaster today, an absolute roller coaster. We spent the whole stream debugging something that was not an issue because I actually got it right on Sunday. I just didn't know how to put it together. I'm reinitializing TA. No, it's static, so I shouldn't be reinitializing it. This should be set once on the first pass through. Unless it is times. Like, hopefully you can see what I'm, like, it's basic trigonometry, right? I want to be able to set the x and y coordinates. Like, it's almost like polar coordinates. Oh, this is. Why am I? I'll just Google it. OpenGL orbit point. Oh wait, can't. That's target point. Just give me the. because what I want to do is I want to set the radius. I'm basically trying to calculate the point on a circle on the XZ plane centered in the center where the triangle is, and I therefore need to work out what the XZ coordinates are over as time goes. And I thought that was just sine of t, which is effectively time but theta, and then multiplying it because I need to basically make the radius bigger, so I'm not like 1 units away from it. I need to be a bit further. The view matrix is static. No, but it won't. The view matrix is static. What a great spot. There we go. Whoa. Whoa. I don't want to make it full screen. I don't support that yet. There we go. That is an outstanding spot. Thank you so much. That was driving me mad. And again, like, I would have eventually probably seen it, and maybe if I wasn't sort of, trying to also talk and present and entertain, then I might have seen it sooner. But full credit to you, because that just went straight past me. But conceptually, what's important here is the triangle is not moving. We are moving. The camera is rotating around it. Although I'm surprised. I don't know what the default for backface culling is on OpenGL. I was expecting it to not be able to see the back of it. Unless it defaults to not cull. G-enable GL cull face. Alright, so you do need to enable it. Interesting. It defaults none. Excellent. I did not know that. That's interesting to know. So let's go to Window, where we do a lot of our GL enabled chuff. That's the debug. So after we set to OpenGL, and then there we go. That's what I wanted. And you can't, I don't know about you, but all I can see is a spinning triangle. My brain can't, because there's no other reference point, my brain cannot see us moving around the triangle, if that makes sense. It looks like a spinning triangle. I'll quickly go through that for Riley, who's just come in and asked a good question. How do we load the OpenGL functions? Because normally you use glad, and you absolutely should use glad, not do what I've done. On Windows, you have to use a special Windows function called WGL get proc address, which will allow you to get the resolve OpenGL functions. This is a very super high level view, by the way, because it involves setting up a fake window to get a OpenGL context, even though you don't have a window yet, blah, 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 blah. But basically, you have to call this function with all of your functions that you want to load, and then I use a little X macro to define them all here with their name, and then this automatically kind of gets, using some macro magic, gets churned through. And yes, I know they all look like Welsh town names. But so basically every time I want to load a new function, I just add it to this list and the system automatically loads it for me. So it's not too much code. It's not too bad. You should go back and watch one of the previous streams, probably the second one. Might even have it in. Yeah, we need to do background screen. We need to do Q maps. There's loads of stuff. There's loads of stuff we need to do. But so we got maths. So we now, okay, so for the next, what do we want to do for the next, like, sort of half hour or so? I don't really want to write any more tests. I kind of feel that's kind of good. We need to commit all this up. Yeah, yes, I think you should stick with glad. We do need to do a cube at some point, which is exciting. Let's have a look. I think we can start. Let's commit all this up, and then I think what we'll do is we'll start building out the debug. We are far away from text rendering. Surprisingly complex. Yes, you're right, texture loading isn't on there because I don't know where I'm going to fit it in, because a lot of the stuff I want to do is just kind of building out, like, you know, the pipeline and getting some buffers in there and stuff like that. So we'll slot it in somewhere. I need to get some 3D models and stuff with some textures and do that. So I think that will just naturally slot in somewhere. Well, cube's actually not too bad, right? Because I can just find the cube data. See if I can find it. I had it the other day. It's really annoying. I saw this the other day and I was like, I must remember where those 36 elements are. Here we go. Okay. No. Will I use STB? I will if I need to load images. I will most certainly use STB. I think people want a cube. I think we need to appease the people. I think we need a cube. I want one with color data. Oh, hang on, fine. Let's just vertex data for a cube with random colors. Just going to ask the Oracle. Here's the vertex data for a cube with random colors, defined as a list of position and color attributes. You don't need to use indexing. You should use indexing. I'm not going to, because that's going to be something we do later. But once we've got the cube there, I kind of want to get something working and then go back and fix it, like improve it and refactor it, because at least that way you kind of know when you've broken something. Like, if you want to know the difference, just go to the docs, right? So you've got up until like C++23. You've got like, you can see here they've got overloads for all the floating point types. So it doesn't matter which one you call; it will just figure out the right one internally. And then you've got the old school ones, which are like synth and synnal for the specific types, because those come from C, because this is in the C math header. But what I'm waiting for is this. This is what I'm waiting for, const expert. And then we can make everything const expert. We do need to do a little bit of refactoring, which I know is not the most interesting, but right, let's see if we can get a cube in there. I have no idea what colours the Oracle has picked either, which is also exciting. Mesh, and then, oh my goodness, this is going to be grim. Oh yes, I'm looking forward to reflection. I'm not looking forward to the syntax because it's like token soup, but I am looking forward to reflection. I think it's gonna be fun. Also, what I found out is potentially making it into C++26 is const for exception, which I think is absolutely brilliant because it's going to be able to make even more. I'm going to be able to handle errors like I want to handle them and make it all const expr. So I'm excited. I'm excited for const expr exception. Okay, so we've got that, and then what this dot color equals that, and then dot x equals, and then dot y equals, and then sorry, I'm just kind of absentmindedly doing this because it's quite like mechanical. What's this? This like that, I think. And then dot r equals dot g. Ooh, steady. Stay on target. I dot g equals, and then rg and the dot b equals, and then just for completeness, because I'll never be able to do this again once the formatter kicks in and has its way with it, f, and then I think I can just do this on each one now. Nice. Oh, I'll better remove those last trading commas as well. Alright. And boom. Unaligned. Okay, right. And now I think we just have to go back to the renderer. Again, this, well, we won't use GL draw arrays soon anyway, but this should all be kind of like wrapped up into it. Like the mesh should be able to say, here's how many vertices that you need to render. Yeah, I could disable the formatter. I just learned to live with it. Right, place your bets. Place your bets. Is this going to work? Is it a cube? I could do a poll, I guess, but I haven't run it yet, so even I don't know. Oh, I'm curious. What do you think? I guess it won't work because the faces are defined as. Oh, is the are you telling me ChatGPT might have not given me the correct answer? I didn't even check it. Oh, nice. I like the colours. I appreciate the colours it's picked. So I guess there's a couple of things. Let's zoom out a bit because this is we are far too close. So one, the data's probably wrong. Two, we don't have depth buffer enabled yet, so who knows what it could be doing. And three, I'm wondering if just like the winding order is wrong on these. No, I think the data's wrong because it's going too fast for me to tell, but I think I would expect to see one face per one. Okay, fine. Oh, and then at the end, I missed the end of ChatGPT's thing. It was like, and here's the index data that you need to draw these correctly. So can you give it to me for calling with GL draw arrays and 36 elements? See if it understands that. Yes, I want to define each one explicitly. Vertex data, 36 vertices, position and color. Okay, it's got it now. I did do a master's degree in computer science, yes. I think we discussed this last stream. And I went to the University of Bristol, which I spelt wrong, but it doesn't matter because where's the Wikipedia page? Because the most important thing to know is the motto has Vim in it, and that is the only thing you need to know about the University of Bristol, is that the motto has Vim in it. Oh, that's a good point. Can I? Because we don't really want to be doing all that miserable formatting again. Can you format that using the following pattern? Dot position equals dot, what is it? Would you say computer science is worth it for game development? I like to make games as a career, but not sure if I should do that or find a course more tailored towards game development. I can't really answer that because I've never worked in the games industry, so it's very hard for me to say what is and isn't right. But like, I think computer science is still is a very good degree. Like, it teaches you. It kind of goes broad and deep depending on, I guess, how your course is structured. So you'll get a lot of fundamentals, which is, no one. My first year of university, I had to implement like a linked list and a hash table, and I've never had to really, apart from in assembly for a few videos, but that's not really the point. Most people never have to write their own linked list, but it kind of gives you the, I guess, like the terminology and kind of the language that other people speak. So if people say, oh, I need to use a hash table for this, like, you kind of know what that means and then what the implications are for that and what the trade-offs are. So as like a, just one example of it, and I think it's one of those degrees that a lot of places just kind of recognize. But I don't think, I'm a big advocate of avoiding degree elitism. There's no, I think if you've gone through university and you've kind of put in the graphs and you've come out with a degree, then I think that says a lot about you as a person. And when we hire, I'm not that fussed about, I'm not fussed at all about where you studied, and I normally only really care that it's like a STEM degree, just because of it kind of aligns well to what we want. While we're all quietly, while we're happy chatting, I'm just gonna do it this way. I deleted it without. That was stupid, wasn't it? I don't remember what I need to do. So I want that dot position equals dot x equals, right. Oh, why does it put the new lines in? Oh, that's horrible. Don't care for that at all. A lot of these. Oh no, that's right. Yeah. Alright, I'm just gonna quickly do this. It won't take too long. It's really not gonna take too long at all. Why this came up before? It's a great question. Why the static keyword if it's already in the anonymous namespace? Just habit. I just typed it by habit. There's no reason for that to be there other than just my own laziness. But do call me out and stuff like that, because I do try to separate my personal idiosyncrasies from what I guess concrete facts. So I do apologise for that one. I'm not going to change it because this is all going to go away soon anyway. B equals, and then finally close off the braces, leave the comma, drop these, something is that right? I feel like it's not. Oh, it's because it's got an extra comment at the end there. Doesn't matter. Let's just see if it blends first. It's fine. I'll allow the truncation. Although, interesting, I thought I had warnings as errors, so I'm kind of confused why that even got through. It's just... This is actually just, because we can use dot, we can just stick this in once and then use dot to repeat the last action. So this will just shove all those Fs in for us. And now the formatting. Right. Missing on position. Thank you. Right. Okay. Place your bets. Place your bets. One. one what? Just one cube, one face, one pixel, one segfault. Yeah, I think my guess is might still look at it will the cube will be conceptually correct, but might still look a bit strange because we've not got the depth testing in. Thoughts? Yeah, it's the culling, isn't it? Well, as part of it, and I still think that it's the depth issue. So what we'll do is we'll revert the culling, because we can just do that at a later date. And then might have to quickly just enable and clear the depth buffer. Yeah, so that is trippy, that. So what we'll do is we'll just I cannot remember what it is. I think it's GL enable. Is it GL depth? Is it? I think it's just GL depth. And then in the renderer, when we do clear, we have to. Where did that come from? Also clear the GL depth buffer bit. Is it GL depth test? Thanks. Yes, nice. No. Well done. Depth buffer is the black and white one that looks foggy in render doc. Yes. Boom. So what I will do quickly is this, and then it's got lots of copy. Right, file, game. Okay, so I'm now running this under render doc, so you can see here it's got this extra like they've injected extra draw calls to print this. So if I press F12 to capture, process, then here we go. You can see the depth buffer here. I think so this is the depth buffer. So what the depth buffer is basically a separate buffer that the graphics card writes to, and rather than rendering like this is the color buffer, this just renders how far the pixel is from the screen, effectively, I guess the viewport. So you'll see here that it's kind of hard to tell, but it gets lighter the further it is away. So what was happening before, if anyone was interested why it looks so trippy, is because OpenGL was rendering one triangle, say the front one, and then it was going, oh, I need to render this one at the back, and then it was just literally painting those pixels over the top of it. It had no idea that one was like physically in front of the other. So, and this is the problem the depth buffer solves, is when it goes to render a fragment, as in it goes to run the fragment shader, it will first check the depth of that and see if there's anything behind it, or I guess in front of it, and if it is, then it won't render it, i.e. all the fragments for the back of the cube are no longer being rendered, because the game knows that, the OpenGL knows that it's just going to be occluded by something, so there's no point in rendering it. So this cube is now even faster to render because we have a depth buffer. What a lot of games do is that they actually do what's called a depth pass first, so they'll just render the whole scene, but just the depth information, so they won't have a fragment shader or have a very minimal fragment shader. And then when they come to do the expensive shading and lighting and all that sort of stuff, the depth buffer is already pre-populated, so it can be even faster. So yeah, I hope that's useful. I think we're going to... let's comment up the code quick. So next stream, Sunday, all being well, what I want to do is refactor everything we've got so that we can render multiple cubes easily and transform them, because at the moment, like... like this is terrible. This is terrible. So what we want to do is basically gut all this so that we have a camera class which encapsulates all this, which we can move independently, and then have it so that we can pass in multiple models, and those models will also encapsulate their model matrix. So then we can just have we can just render loads of cubes and loads of different transformations, and maybe even do some event handling so we can actually move the camera around. I think that'd be pretty cool. I think that'd be a good thing to shoot for next stream. So yeah, just gonna comment this up. Where do we get to? So we let's just commit add comparator to add equality to matrix 4. Commit to vector 3. Model uniforms versus instant rendering with model matrices and buffers. I think we will just see how it goes with what we need. I will probably switch to UBOs, so uniform buffer objects, at some point, just because I think it's slightly easier to work with and it's a bit more modern than just sort of like arbitrarily calling GL uniform. I don't know if we're going to need instant rendering. We'll see how we get on. Twitch affiliate when? Well, I believe this is the stream I need to take me over the threshold to be able to apply for affiliates, because I needed 7 streams in a 30-day period, and this will be the 7th one. So maybe next Sunday will be affiliates, or however long it takes to be approved. This plugin is called LazyGit. It's an absolutely incredible plugin. It works on the command line as well. In fact, it's first and foremost a CLI. I just happen to have the NeoVim plugin that renders it as like a NeoVim window. But this is not specific to NeoVim. This is purely a CLI. Yeah, LazyGit is absolutely brilliant. It also supports mouse as well, which is kind of how you can kind of click around and do stuff. Let's see where we're at. So mesh renderer window. So let's do commit add unit tests, and then I think we can just do commit render cube, and then I'll go for I'll tag, and then I'll do hoping that would tell me Anyone want to tell me what stream this is? I think it's 6. 6? Yeah, it's thank you, Jason. Yeah, I really like consistent workflow and kind of stuff just to work in and out. So, who said 7? Come off it. Well, we've gone for 6. I can see the tags somewhere in this. 3 tags. I also have the wrong email address set up on this, which is exciting. I still have the email address I used for when I did my last engine, which probably should be my personal one now. Whatever, don't care. Just push it up. Just stick it in the Git hole and move on. Oh, did I tag the wrong commit? Oh, what an absolute nightmare. It's all right. Lazy gets figured it out. It's like, you're an idiot. Let me do what you actually want to do in the first place. Excellent. Well, I think that is. I'm just going to leave that up here for a bit. Slap that in the thumbnail for people to see. Put a community post out saying, everyone, here's what we've been doing. We're at spot on 2 hours as well, which is nice. I think it was kind of funny to kind of do all that debugging, even though we didn't really need to. But I think it's good that kind of forced us to set up a testing framework, which means we can now add to that in the future as we go along. I think it kind of highlights just the complexities of what we're going to do in the fact that it was right, but not. It's not conceptually right. Do you see what I mean? Because you look at it and the problem with graphics programming, especially at this kind of early stage when it's all just sort of primitives, you get into your head the idea of what you think it should look like, and then you render it and it doesn't look like that, and then you go, well, I thought it should look like this, so therefore it's wrong. And it's I think I myself need to kind of be a bit more cognizant of the fact that actually maybe it is right and just my preconceived idea is wrong. And yeah, that's an excellent point by Jason there. It's good to know that the kind of the core maths of the graphics is like correct before we go off making a game, because what I don't want to do is spend 3-4 more streams and we're deep in the bowels of implementing I don't know, screen space ambient occlusion, and it turns out there was a bug in the matrix code, and that's why that's a hot mess. That will be a hot mess when we get there, but that's a joy for a future stream. I'm going to call it there because it is now 10 o'clock and uncharacteristically I'm probably going to have a beer, although it is Christmas in the Bags household now, so there is a bottle of port as well, so I might open that. We'll see how we get on. I hope everyone enjoyed it. Thank you very much for coming along, much appreciated as always, and hopefully we'll see you on Sunday when we will have this but more.